Hello everyone. In this video, let us see an important interview program called program to check given number is prime or not. So you all know the prime number definition. So that is if number is divisible with one and given number only, so then it is called a prime, right? Okay. So observe this: if number is divisible with one and given number only, then it is called prime number, right? You all know this, okay? So one more thing before going to watch this video, first of all, so gone through the perfect number video. So in that one I explained how to generate the factors in a number. So it is extension to that, okay? So that one helps you to understood this one so easily, okay? So first of all, I'll explain the methodology to design the program here. So observe everyone. First, let us take value 5 here, input 5. So we need to check whether this value is divisible with each and every value or not. Okay. So what values we need to consider? So from 1 to 5. Okay. We need to check whether this value is divisible with each and every value or not. Okay. So here what happens, so it is divisible with only 1 and next of also the 5. Okay. So means here you can notice one thing. So if number is having only one or two factors, okay, so then we can say that it is a prime. Okay. So means initially we take some count variable to 0 here, and so whenever we found the factor, okay, so let us take, so this one, this is the factor next. So this one is not possible. So these are not possible. As again, this is possible, right? Okay. So here you can check. So count increments for two times. Okay. On dividing, so 5 with 1, so it'll get remainder 0. It's a factor. On dividing, so 5 with 5, as again we get remainder 0 again. So we are going to increment, so count for by 1. Okay. So means two times we need to increment the count. After that, we need to check whether the count is true or not. Okay, let us check. So the second input here, so that is called 4. Okay, so we need to check. So this 4 value is divisible with all these values or not. Okay, 1 to 4. So yes, 4 is divisible with 1, as we need to increment count by 1. Again, as it's divisible, as count we need to increment by 1, and now it's not possible. 4 is not divisible with 3, as now it's divisible. So here count increments for 3 times, okay? So means apart from 1 and given number, so factors, it is having some other factor, okay? So that's why we say that it is not prime. So I hope so understood. So the thing here, first of all, we should collect the input from the user, and next of all, we need to initialize the count variable to 0 here. After that, we need to generate the range of values from 1 to n here. And next to that, we should check whether each and every value is divisible with the given value or not. Each and every value we should check whether divisible with the given value or not. If for suppose if it is divisible, we should go for incrementing the count by 1. Okay. So after completion of the loop, we should check whether the count we got 2 or not. Okay, if we got 2, we should go for printing prime. If not, so we should go for printing not prime. Okay, so this is way for designing the solution with count model. Let us finish this one. So, okay, fine. So first, we should collect input from the user. So next, what I said initially, we should initialize count to 0. Next, we should generate the values from 1 to n here. Next, should check whether each and every variable value is divisible with I variable value or not. So given value is present in n variable, right? So all values from 1 to n we are getting into I variable here. So we are checking so n variable value is divisible with I or not. So if we get remainder 0, so then I variable value is factor for n, right? Okay. In that scenario, we should go for incrementing count by. After completion of for loop, we should check whether count is 2 or not. If count is 2, we should go for printing prime. If not, as we should print it's not prime. So I hope so everyone understood. So this, let us check. So by passing the inputs, 5 it's prime, next 4 it's not prime. Okay. It's working for different inputs. Okay. So fine, there is no problem in it. So here I'm not explaining any base conditions here. So that is for input 1 and for negative values. Okay. So the main logic here I'm explaining from values 2 onwards. Okay. So if for suppose if you want to check for any values like 1, 0 and negative values, we need to induce the base condition here. So that's it. Okay. So I hope you understood. So but the thing is how much time complexity it is taking. We need to check that. So if you observe this, if you take input value 12, loop it is going to take 12 iterations, right? So if you take value 31, loop runs for 31 times. Based on loop only, we judge the time complexity, right? Okay. So here, based on n value, so we are getting the number of iterations. That's why I'm taking the time complexity as order of n here. Okay, which is high. So we can reduce this time complexity. Okay. So what was that? Alternative method. Let us see now. Okay. So here we have one more thing. The reverse logic. That is, if number is divisible with any one of the number in between 2 to half of the number, then it is called not prime number. So the definition we are taking for not prime here. Okay. So that's it, right? If number is divisible with one and given number, then we say prime means. If number is divisible with any one of the number in between 2 to half means it's not a prime. Okay. So why we are taking half means you all know. So we get factors. So up to the half, after half of the number, what is the next factor? Given number only, right? Okay. So that's why. I used this one. So you can check now here. 5, let us take input 5. So it is not divisible with any one of the numbers. So in between, 2 to 4 here. But if you take the 4, it is divisible with 2 itself. So there itself you can stop, okay, that it is not prime. And we can stop the program. So it takes some few iterations. For not prime numbers, so it takes some few iterations, so the time complexity reduces. Of course, for prime number, so it takes some half of iterations, okay? But when compared to the previous one, so it reduces here, okay? So let us try to implement that one. Observe everyone. Instead of 1 to n plus 1, so now I am running loop from 2 to half, okay? So 2 to half here. Now count not required. So what I am doing here is, if number is divisible with any one of the numbers, so in between 2 to half, okay? So there itself I'm printing, so it's not prime, and I'm stopping the loop. So with the help of break, I'm stopping the loop, okay? Let us take so value 12 here, okay? So 12 is divisible to itself, right? Okay, it's not required to check with the remaining numbers, okay? So just it takes one iteration, okay? And compared to the previous one, how many iterations are reducing here? So okay, just gone through that, okay? For suppose if you take so input 31, okay, so it checks for all values in between 2 to half, okay. So 31 is not divisible with any one of the numbers in between 2 to half, okay. In that scenario, loop is going to be ended, right? Okay. So in Python, we have one flexibility so called. So if for loop ends, okay, so then outside of this we can take so the else. We can take for else combination in Python. So means if loop stops in the intermediate stage itself, okay, so then else block is not going to be run, just like if else, okay. So for suppose if for loop ends by reaching to the stop value, so then else block is going to work here. So observe carefully, I'm taking else outside of for loop here, okay, okay. So here what I'm printing, it's the prime for 31. So it iterates from 2 to 15 is not divisible with any one of the value. So finally loop ends afterwards, control comes to else block and it prints prime. Okay, let us check so whether it works or not. For 12, as it's printing not prime, and for 31, as it's printing prime, as it's working for. So both the inputs here. So I hope you understood. So here half of the iterations reduce it. We should take worst case time complexity, right? For prime numbers, we get the worst case. So that is nearly order of log n time complexity. So we can observe here. Half of time complexity reduced. So if loop iterates for half of number of times, you can take so order of log n, okay? So here traditional method of so calculating time complexity, but in short, you can remember this, okay? Easy way. So next, still we can reduce the time complexity of this one, okay? So how is it possible means with the help of square root, okay? So you all know, so square root gives you the smaller values results for the bigger values, right? So let me type and show you at once. So let us check for square root of 4, it's 2, square root of 9, it's 3, square root of 16, it's 4, square root of 25, it's 5, square root of 36, it's 6, okay? So here we can check. So for bigger values, we are getting so the smaller results, right? Okay, you can clearly understood this. So now what we want? We want to reduce the number of iterations in the loop, right? Okay. So for that sake, let us try. So by running so the loop for square root number of times, whether it works or not, let us check. Okay, with some sample values. So let us take some square root of 5, 6, 7, 8. So for all these values, we'll get square root in between 2 to 3, right? Okay, 2 point something you'll get. So we are starting loop from so 2 now, right? Okay. So here we are getting result in the float form, right? How we can remove this float form? So by applying int to the square root of n, so we can remove this float part, okay? So loop is actually starting from 2. So if you take, so in stop position as int of square root, okay, you will get 2. Means loop is not going to be iterated for at least once also. That's why we are going to take like this, that is plus 1. So that what happens, the loop is going to be started with 2. And so in stop, we are going to take 3. Loop iterates for only one time. So for value 2 only it runs, okay, for these inputs. For 5, 6, 7, 8, okay, loop iterates only for value 2, okay. And one more thing, so this square root of n, you can return like this, okay, that is n power 0.5. It's not required to induce the square math module and using square root function also, okay. So let us try this one, okay. Let us check so whether it works or not. Int of n power 0.5 plus 1, okay. Next, so let us check whether it works or not for these inputs now 5, 6, 7, and 8. Okay, first let us check for 5. So for all these values, loop iterates for only this. Okay, only for two value it iterates. Check whether 5 is divisible with 2 or not. 5 is divisible with 2. Okay, no, it's false. Loop ends and control comes outside of the loop, it prints prime. Okay, let us check for 6. 6 is divisible with 2. Yes, it's true. It is going to print not prime and it stops the loop. It is not going to execute else block. Let us check 7. 7 as it's divisible with, is it divisible with 2? No, false. So loop ends by reaching to the stop value, control moves to else block and prints prime. Okay. Let us check for 8. 8 is as divisible with 2. It goes for printing not prime. So it's clear that now so it's working for these inputs. I can check for bigger values whether it works or not. Okay, 5, it's working, prime. 6, not prime, it's working. 7, prime. 8, not prime. Let us check 31. So prime. Now you can imagine how many iterations are reducing. So let us take square root of 31 now. Okay, it is something 5 point something you'll get, right. Okay, so loop is iterating from 2 to 5 values, 2, 3, 4, and 5. So only 4 times it is going to be iterated now. Okay, earlier previous program it iterated for half of number of times. Now you can check. So again, a number of iterations are reduced here. Okay, I hope so you understood. So how it's working here. Okay, how the time complexity is reducing. So this is nothing but order of square root of n. Time complex it's taking here. So so this is prime number program. Hope so each and everyone understood. So this okay. So again, this program is important with recursion also. So I'll keep one more video. So regarding that, go on through that one also. Don't skip. Okay, these are important. So not only just for interviews. Okay, these are important for coding section also. Okay. So you can gone through some tries like Wipro and TCS repeatedly. So programs are asking based on this. Okay, it's important. So that's it. Thank you, everyone. Let us meet in the next video.